Being a college student in a generation in which technology, news, and social media are constantly present all around us, it's kind of difficult to never have heard the word fracking before. Protests, newspaper articles, and documentaries alike have all covered the issue over and over again. But do we ever stop and ask ourselves what fracking actually is? Well, after writing an editorial about the issue for the past couple of weeks, I have noticed that a lot of people, like myself when I started out, had no clue about the details of the process or the impacts that fracking actually has on our own environment. Now, by no means am I a scientist or an expert on the issue, but the goal of this video is that by the end, anyone who watches this will hopefully know more about fracking than before. So let's get down to the basics. Hydraulic fracturing, more commonly known throughout the United States as fracking, is a mining technique that has been around since the late 1940s. However, the relatively new methods used today have only been around for 20 years or so. Hydraulic fracturing is mainly used to create deep fractures within rock formations in the earth by injecting pressurized liquid into man-made wells with hopes of extracting natural gas. Although types of fracking vary depending from mining company to mining company, there are usually 5 main steps that each hydraulic fracturing mine follows. Step 1. The acquiring and transportation of water. The starting point of every fracking mine, regardless of the situation, is the acquiring and transportation of water to be used in the drilling process. Massive amounts of water are usually taken from both ground and surface water resources to be used in the hydraulic fracturing process. Quoting from the U.S. Environmental Protection Agency, an estimated 70 to 140 billion gallons of water are used to fracture 35,000 wells in the United States each year. This is approximately the annual water consumption of 40 to 80 cities, each with a population of 50,000 people. Fracture treatments and coal bed methane wells use on average 50 to 350,000 gallons of water per well, while deeper horizontal shale wells can use anywhere from 2 to 10 million gallons of water. According to the Earthworks article titled Fracking 101, it's been said that the transportation of 2 to 5 million gallons of water adds up to about 1,400 trips by tank trucks. Saying that, not only does fracking waste immense amounts of water, but it also burns tons of fossil fuels, creating a very large carbon footprint. Step 2. Chemical additives and proppant mixing. Once delivered to the well site, the acquired water is combined with chemical additives and liquids called proppants to make the hydraulic fracturing fluid. To keep the spaces within the newly drilled wells open and accessible, it is very common for companies to use methods such as proppants to make sure the water remains easily extractable. A proppant usually varies in substance. However, the material can be anything from biocides to keep organisms from clogging up the fissures, to other man-made chemicals such as hydrochloric acid, zirconium oxide, and sintered bauxite, which are known to be not only toxic, but mutagenic and carcinogenic as well. Step 3. Horizontal well drilling. When discussing traditional mining techniques that are prevalent throughout the world, the one most commonly used is known as vertical drilling. Vertical drilling is more or less a constant pipeline placed directly downward until the target formation within the rock is reached. Hydraulic fracturing, on the other hand, uses a technique known as horizontal well drilling. Horizontal drilling initially starts out the same way, until the drill reaches the underground oil and gas formations. It is there when the drill operator turns the drill bit so the pipeline begins to go in a horizontal direction. With the pipeline going horizontally, the drill can now continue to go for greater distances while still being within the gas and oil preserves found within the Earth's surface. Step 4. Injection and recovery of hydraulic fracturing fluid. Pressurized hydraulic fracturing fluid is injected into the well with pumping units, creating cracks in geological formations that allow oil or gas to escape, which will eventually be collected at the surface. Usually, a mixture of frac water and various chemicals are pumped into the Earth's surface. However, injecting propane, nitrogen, and sometimes even acid into the formations are used to clean out wells and make the flow of fluids more easily retracted. The highly pressurized water is then withdrawn from the cracks where it mixes with other materials within the rock formations such as benzene, uranium, and radium. Although the exact amount is not known, Multiple studies have shown that prior to extracting hydraulic fracturing fluid, 90% of it continues to remain underground. Potential impacts which can arise with the retraction of frac water is the contamination of groundwater and natural aquifers due to the poor quality of well construction, and also the likely situation where water withdrawn from the cracks mixes with toxic materials within the rock formations and brings them to the surface. Step 5. Frac water treatment and waste disposal. Fracturing fluids that rise to the surface are referred to as flowback fluids. Flowback fluids oftentimes remain highly toxic once extracted from the ground and pose a significant threat to the environment if not dealt with correctly. Usually after the fracking process is complete and the water is retrieved from the newly drilled wells, the frac water is then placed in massive stagnant pools until it can be properly disposed of, if at all. During this time, the water not only poses threats for plants and animal life, but also has the capacity to leak into freshwater aquifers located underground and also be transferred to lakes and rivers within the surrounding area. The wastewater that comes from the fracking process can be dealt with by multiple ways. It can either be disposed of by it being injected deep underground, dumped into the surface of surrounding bodies of water, or finally, and definitely the most environmentally responsible, recycled for future hydraulic fracking sessions. So there it is, the steps of fracking summed up in a little less than 10 minutes. All in all, hydraulic fracturing is a method which makes extracting oil and natural gases from underground easier and more dynamic. But although highly efficient, it has recently gained a lot of negative criticism due to its correlation with high levels of air and water pollution. Hopefully after watching this video, the information learned about the various harmful effects that fracking poses to our world will spark your interest and make you want to do something about it. Speaking with local government officials or researching healthier fracking alternatives are two ways in which we can solve this pressing issue. Until hydraulic fracturing companies figure out ways to become more environmentally sustainable, the condition of not only our country, but our world is at stake.